Hey, topic in life's math and history, and we are going to be adding and subtracting the square roots. So, we are going to investigate what happens when we add them and subtract them. So, for a warm-up, we're going to try and answer and solve these kind of expressions and see what happens and find out because there's a pattern. So, with 5x minus 4x, we could easily agree that that is equal to x. On the second one, we have 2y plus 5z. When you do that, you can't really simplify. So the answer is cannot simplify. With the third one, this one's a little bit large. But when we combine like terms, because we have 15a, 12a, and 7a, we are going to be able to get 3a plus 7a plus b. 3a plus 7a is 10a plus b. So that is our simplified answer. We can't merge the 10a and the b because that's basically adding apples and oranges. Let's try and do the final one. 2x squared plus 8x minus 4x. So basically, when we did that, we're going to have to merge the 8x and then negative 9x. That will become a negative 1x, or negative x. So 2x squared minus 1x. And that is the beginning of a warm-up. Do you notice anything strange about the 4 questions or the 4 problems in this warm-up? Well, every time we solved each of the 4, we would always solve by combining the like terms. Like the second one, you cannot simplify because that's a y and that's a z. With these, the 3 a's can be turned into one single 10a, but you can't merge the b. With the last one, you merge 8x and 9x to get negative 1x, but you can't merge 2x squared because that squared is preventing it to be merged with this one. That squared must stay alone. So, what we're going to be doing today is, we can understand that we can use combined like terms when we add and subtract the square roots. Because when we try to combine like terms with expressions and equations, or whatever kind of math you are doing, you will always find to have the same variable. That is basically like 2x plus 3x equals 5x. You're going to have the same exponent. And that is technically saying x squared plus 3, or x squared plus x cubed. That's going to be x to the 5th power. And last but not least, we're going to have the same square root. And that is basically saying a square root merged in with another square root. You cannot merge if you have a cube root or anything else. It must have the exact kind of value or exact kind of operator, like variables with x squared. The same variables and the exact same roots. So let's start investigating why we have to use combined like terms when we add and subtract the square roots. Okay, so here is our very first example. We have 4 times the square root of 5 plus 3 times the square root of 5. So, what do you think the answer is going to be? Type in the comments below what you think, how should we solve this, and how and what the answer is. Okay, if you pause the video, you'll have more time to do it. 3, 2, 1. So we are going to explain right now. So you see how in the warm-up we were combining like terms if we had the same variable, the same exponents, that are with variables and the same root, what we can do is, do you remember how we were using combined like terms? What we can do is, since that this is a 5 and that is a 5, and the 4 and the 3 are basically the same thing with the square root of 5, that's saying that 4 times the square root of 5 and 3 times the square root of 5. We can merge the two to write the answer as 7 to the square root of 5. What you gotta do is add the 4 plus 3 to get 7, because these two will cancel out and be the exact same thing. So here's scenario 1. When you have a number being multiplied by the exact same radicand inside the square root, then it's easy to just add the two to put it in here. Here's an example. If you have a, the square root of b, plus c, the square root of b, that is the same thing as saying a plus c, and you're going to get the sum of a and c together to get the square root of b. So a plus c, square root of b, is going to be your answer, or your formula. But in this case scenario, it's the 7 times the square root of 5. Let's look at another example. Okay, so here's our second example. We are adding the square root of 2 and the square root of 18. But this time, we have no numbers being multiplied in front of the square roots. So here's scenario 2, adding the square roots without the multipliers. Pause the video and comment what you think should the math look like and what the answer should look like. Answer in 3, 2, 1. Okay, so let's answer. What we're gonna do is, since 18, even though it's not a perfect square, we can pull a few numbers out of it. The number 2 has to stay the same because you can't pull any numbers from it, meaning it's the most simplest form you can work with. So we're going to do the square root of 2 plus 2 and 9 can both be pulled out of the square root of 18. Because 2 times 9 does equal 18. So since 9 and the square roots of 2, so 2, the square root of 2 plus the square root of 2 again, plus the square root of 9. Actually, we have to multiply them because 2 times 9 is 18. We can pull out the square root of 9 to make a 3. When we do that, we can put the 3 in front of the square root of 2. So 3, the square root of 2. There's one more step. We have the 3 square root of 2 plus the square root of 2. Imagine there's an imaginary number. So applying back to the previous example, or the previous rule, what we can do is merge the two. When we do that, we get an answer of the 4 multiplied by the square root of 2. And that is our second example and second answer. When you have no multipliers but just square roots, try and pull a few numbers out and merge the two to try and get to an answer. That is the second scenario. Let's take a look at the third scenario. Okay, so here's the third scenario, which is actually easier than you think, because you probably understood how to square root perfect squares before you watched this video. Like, here's an example. The square root of 100 is equal to 10. And before doing any kind of rewritten math and expanding things and taking numbers out of the square roots, you might want to ask yourself, well, is this a perfect square? And it appears on this video that we do have perfect squares. The square root of 49 and the square root of 81. Let's see what happens. So, 7 times 7 will become 49. And 9 times 9 will become an 81, which means all we have to do is find the square root of that and the square root of that. So 49, the square root is going to be 7. Subtract that by, because of the operator, the square root of 81 is 9. So now we have an easy math equation, 7 minus 9. And when you subtract 9 from 7, you are going to get an answer as negative 2. The third scenario is actually easier than you think, because you always want to ask yourself, is this a perfect square? If yes, then you got to take the express elevator to your answer. Let's look at the final scenario, which is a challenge problem. So it's basically a bonus time. Okay, so here's the challenge problem. Scenario 4. When you are trying to solve a gigantic equation, but it's very hard to tell what to do, and it's very, very big. So let's get started. The first thing we gotta do is try and pull out the numbers of every square root we have. When we try and do that, we have to put them in the exact same square root of something. When we do that, we can also combine. Here's an example. 12, we can pull out two numbers, the square root of 3 and the square root of 4. 4 can be used to pull out a number, which is going to be 2. Let's do the second one. 27, we can pull out the numbers, the square root of 3 and the square root of 9. Since 9 can have another number that can be pulled out without, when you eliminate the square root, it will become 3, because 3 times 3 is 9. And the last one is a 48. When we do that, we can pull out numbers as the square root of 12 and the square root of 4. But there's another problem. Since 4 can have another number pulled out, that's going to be 2. So we're going to drag that up here and do 2 to the square root of 12. But we have another problem. Since 12 is not simplified to its most, we can write 3 and 4 again and square root them. When we do that, we can turn the 4 into a 2, multiply that with the other 2, just like from the last video, and we're going to get an answer of 4, the square root of 3, because 3 is our simplest form. That's just for the third one. But what about the other ones? Well, 2 the square root of 12, we pulled out a 3 and a 4, and we have a 2 right there. So we're going to put that 2 up here and multiply that 2. So now we have 4 with a square root of 3. The second one, negative 6 square root of 27. We said 3 and 9 make 27, and we have 3. So that 3 is going to drag up to the negative 6 and become a negative 18. Now we have the square root of 3. So now we have a new equation. With the 3 remaining parts, we can now easily combine like terms to solve the problem. So 4 the square root of 3 minus 18 the square root of 3. Then we have to add that by the square 4 the square root of 3. So let's see what happens. Going back from the very first scenario, we can add and combine like terms with the square roots if they have different or the same multipliers and the same square roots. So we have the same square roots and we have multipliers. So now we can easily combine like terms and add the 3. So 4 plus negative 18, that is going to become negative 14 with square root of 3 plus 4 square root of 3. When we do that, we get our final destination and our final answer as negative 10 to the square root of 3. And that is how we solve the super challenging problem. So when we try and solve these large problems, it's a good idea to try and pull out numbers to get to a more simplified answer and try and combine them by having different or the same multipliers and the same square roots. And that is how we can add and subtract the different square roots. To understand this in real life, if you ever want to go into an engineering field, or if you want to build things or solve problems, no joke, but square roots is actually one of the things you will learn in engineering. So when you build something or engineer something, you will have to use square roots, no joke, because you can't use numbers that keep going on and on and on and on and on. For example, if you're an engineer at NASA and you are using an irrational number like 3.141419 blah 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 blah, and it keeps going forever and never and never, when you work in an engineering field, you can never use irrational numbers because that tiny bit off accuracy that's inaccurate will actually throw a rocket off course, or worse, it would crash. So when you try to use square roots, it's more accurate because you can tell your coworkers and your friends what number you want and you can pinpoint it with 100% accuracy. So if square roots never existed in the first place, then this would have happened. So that is why we need to understand and learn about square roots. I hope this video has helped you. Thank you for watching Top Realized Math Industry. Like and subscribe.